NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math lesson on factoring polynomials using the cube of a difference identity. This is a powerful technique that can help us solve complex factorization problems efficiently. Let's start by understanding the cube of a difference identity. The formula states that a cubed minus b cubed equals a minus b cubed, or more explicitly, a cubed minus 3 a squared b plus 3, a b squared minus b cubed equals a minus b cubed. This identity is very useful for factoring certain types of expressions, as we'll see in our examples. Let's look at our first example. We need to factorize x cubed minus 3x squared plus 3x minus 1. Let's compare this with our identity. If we set it equal to x and b equal to 1 in the expanded form of our identity, we get x cubed minus 3x squared times 1 plus 3x times 1 squared minus 1 cubed, which equals x cubed minus 3x squared plus 3x minus 1. This matches our expression exactly, so we can now apply our identity to factorize it. The result is x minus 1 cubed, which we can also write as x minus 1 times x minus 1 times x minus 1. Now, let's move on to our second example. We need to factorize y cubed minus 6y squared plus 12y minus 8. This doesn't immediately match our identity, but let's try to see if we can make it fit. Let's try it equals y, and b equals some value. We need to determine what b is. Looking at the last term, negative 8, we know that's negative b cubed. So b cubed equals 8, which means b equals 2. Let's verify. If it equals y and b equals 2, we get y cubed minus 3y squared times 2 plus 3, y times 2 squared minus 2 cubed. That's y cubed minus 6y squared plus 12y minus 8, which matches our expression. So the factorization is y minus 2 cubed, or y minus 2 times y minus 2 times y minus 2. Let's try a more challenging example. We need to factorize x to the 6th power minus 3x to the 4th power plus 3x squared minus 1. This doesn't look like our identity at first glance, but let's be creative. What if we substitute a equals x squared and b equals 1? Let's see what happens. Using the identity with these substitutions, we get x squared cubed minus 3 x squared times 1 plus 3 x squared times 1 squared minus 1 cubed. Simplifying, we get x to the 6th power minus 3x to the 4th power plus 3x squared minus 1, which matches our expression. So the factorization is x squared minus 1 cubed, which we can write as x squared minus 1 times x squared minus 1 times x squared minus 1. We can factorize further because x squared minus 1 can be written as x plus 1 times x minus 1. So our final answer is x plus 1 cubed times x minus 1 cubed. Let's summarize what we've learned about factoring using the cube of a difference identity. First, we identify expressions of the form a cubed minus 3 a squared b plus 3 a b squared minus b cubed, which can be factorized as a minus b cubed. Second, we need to determine the values of a and b by examining the first and last terms of the expression. Third, we verify that the expression matches the pattern of our identity. And finally, we can sometimes factorize further by breaking down the factors. This technique is particularly useful when you encounter polynomials with 4 terms that follow this specific pattern. I encourage you to practice this technique with other polynomials. Look for expressions with 4 terms that might fit this pattern, and try to factorize them using the cube of a difference identity. We need to factorize the expression a cubed minus 6 a squared plus 12 a minus 8. First, let's try to identify if this matches our cube of binomial formula pattern. In our formula, we have a cubed minus 3 a squared b plus 3 a b squared minus b cubed. Let's compare. For the first term, we have a cubed, which matches our formula. For the second term, we have minus 6 a squared. In our formula, this would be minus 3 a squared b. So if we compare, 3 a squared b equals 6 a squared, which means b equals 2. Let's check the third term. We have plus 12a, and in our formula, we have plus 3ab squared. So 3ab squared equals 12a. And if b equals 2, then 3a times 4 equals 12, which confirms our value of b. Finally, for the last term, we have minus 8, and in our formula, we have minus b cubed. So b cubed equals 8. And if b equals 2, then 2 cubed equals 8, which again confirms our value of b. Since we verified that b equals 2 throughout, we can factor our expression as a minus 2 cubed. Let's move on to our second example. We need to factor the expression a cubed x cubed minus 3 a squared x squared plus 3ax minus 1. Recall our cube of binomial formula. A cubed minus 3 a squared b plus 3, a b squared minus b cubed equals the cube of a minus b. Let's match our expression with this formula. First term, a cubed x cubed matches with a cubed from our formula, so it equals ax. Second term, minus 3 a squared x squared matches with minus 3 a squared b, so if it equals ax, then b equals 1. Third term, plus 3ax matches with plus 3ab squared. So if it equals ax and b equals 1, we get 3ax times 1 squared, which is 3ax. This confirms b equals 1. Fourth term, minus 1 matches with minus b cubed, so b cubed equals 1, which means b equals 1, again confirming our value. Since we verified that it equals ax and b equals 1 consistently, we can factor our expression as the cube of ax minus 1. Let's tackle a more complex example. We need to factor the expression a to the power of 9b to the power of 15 minus 3a to the power of 8b to the power of 14 plus 3a to the power of 7b to the power of 13 minus a to the power of 6b to the power of 12. This looks complicated, but we can apply the same strategy by matching terms to our cube of binomial formula. First, let's try to factor out common terms. Notice that a to the power of 6, b to the power of 12 is common to all terms. Let's factor that out. After factoring out a to the power of 6b to the power of 12, we get a to the power of 6b to the power of 12 times the quantity a cubed b cubed minus 3 a squared b squared plus 3ab minus 1. Now, the expression inside the parentheses matches our cube of binomial formula, where it equals ab and b equals 1. Therefore, our final factorization is a to the power of 6b to the power of 12 times the cube of ab minus 1. Let's summarize what we've learned about factoring polynomials using the cube of binomial formula. The cube of binomial formula states that a cubed minus 3 a squared b plus 3 a b squared minus b cubed equals the cube of a minus b. When factoring polynomials using this formula, step 1, identify if the polynomial matches the pattern of the cube of binomial formula. Step 2, compare the terms to find values of a and b. Step 3, verify that the values of a and b are consistent across all terms. Step 4. Express the factored form as the cube of a minus b. Practice more examples to become proficient with this formula. It's a powerful tool for factoring certain types of polynomials that would otherwise be challenging to factor. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.